Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on September 10, 2025, just yesterday. The headline claim is clear. This paper argues that reinforcement learning is the key driver turning large language models into large reasoning models, especially when rewards are verifiable, and it maps the algorithms, data, and infrastructure needed to scale. The paper is titled, A Survey of Reinforcement Learning for Large Reasoning Models, and the implications for model training are quite significant. It highlights reward design, critic-free optimization like GRPO, and asynchronous systems as shaping the new scaling laws for long-form reasoning. Also, the authors shared an actively maintained GitHub repo compiling RL for large reasoning models. You will find a curated paper list, concise takeaways, model and dataset links, news updates, and topic sections like foundations, training resources, applications, and future directions. It reads like an organized, evolving survey hub. Well, Figure 1 frames the survey's roadmap. It links components, problems, resources, and applications into one reinforcement learning loop for reasoning models. The central diagram shows an agent interacting with an environment, which means the model takes actions and receives rewards that guide learning over episodes and training steps. The left panels group methods for rewards, policy optimization, and sampling. The middle panels list data and infrastructure. The right panel maps where these capabilities apply, from coding to robotics. Alright, Figure 2 sketches the trajectory of reinforcement learning methods and what that means for task-solving capacity. The chart contrasts RL from human feedback, direct preference optimization, and RL with verifiable reward, then points to open-ended reinforcement learning as the next step. Verifiable reward means the model gets a checkable score, like passing a unit test, which enables reliable scaling. The message is that capacity rises as training shifts from preference signals to rule-based verification, and potentially to open-ended discovery. So Table 1 serves as a snapshot of open-source reasoning models, showing how algorithm choices and architectures line up with modalities and scale. The table lists models across months, which helps compare critic-free methods like GRPO against alternatives such as CISPO or OPMD. Mixed preference optimization means combining different feedback signals to steer training, which can stabilize learning across tasks. Several entries span text and vision, signaling multimodal reasoning momentum. So Table 3 compares reinforcement learning algorithms for reasoning model training, highlighting how they estimate advantage and control importance sampling, which strongly affects stability and sample efficiency. Advantage refers to how much a chosen action beats the baseline, and group relative estimates use several sampled answers to form that baseline. The table shows a shift from critic-based PPO to critic-free families like GRPO and CISPO, because removing the critic cuts overhead. Loss aggregation switches between token level and sequence level, signaling different credit assignment granularities. Wrapping up, two takeaways stand out. Verifiable rewards unlock scalable reasoning, and critic-free optimization with asynchronous systems makes that scaling practical by cutting overhead and boosting throughput. The broader implication is clear. Reinforcement learning is a complementary path beyond supervised fine-tuning toward open-ended, tool-using intelligence. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.